Okay, we are ready for our next video. This one is going to cover the log rule called change of base, which is a pretty neat log rule because it provides us some functionality that we can use our calculators for that allows us to do problems that we potentially may not be able to do. So what happens is, if you look at a scientific calculator, I'm going to pull one up here. Scientific calculators typically have a LOG or a common log button and an LN or a natural log button. This happens to be a Texas Instrument version. Here's a Casio. On the Casio, the log button's here, the natural log button's here. If you're not using a scientific calculator, maybe you have an instructor that allows you to use a graphing calculator. This is a TI-84, for example. Again, we see that LOG button and we see the natural log button. So these are the two log buttons that most commonly show up on calculators, which is great if you want to evaluate a common log or a natural log. We can just use those calculators to do that for us. The problem is occasionally you might be given a problem, like these two examples I have down here, that base is not 10 or it's not E. So unless you have a calculator that actually has a change of base button on it, you're stuck. And that's where this change of base formula really helps you out. Because what it does is, if you're given a problem where that base is not 10 or is not E, you can actually rewrite that log as the division of two logs. As long as you make that base the same, you can make it whatever you want. You could make them both 2s, both 3s, both 6s. Now, why you would want to do that, I don't know. If you're going to use your calculator, it would behoove you to make them both a 10 or both an E, because we have buttons on the calculator that we can use then to do the problem. And so the generic formula says, hey, changes base, you can write it like this. The log of A to base B could be rewritten as the log of A to base C divided by the log of B to base C. So again, the key is that these bases must be the same, and the argument gets put up top into that log, and the base gets put down into the bottom or the denominator. The rule has been rewritten here where I've just converted both of these happen to be base 10, both of these happen to be base E. You can use whichever one you want. You'll get the exact same answer out of the calculator. What I do recommend, this note I have here, is whichever format you choose, if you want to do this problem in a calculator, please do the problem twice. Make sure you get a duplicate answer, because this rule in of itself is not difficult. It's one of the most straightforward log rules that we have. Where students tend to make a mistake is when they're actually putting it into the calculator, they do something wrong. And so I'm going to show you both of these examples. We're going to rewrite them using these formulas, and then we're going to put it in the calculator to make sure that you know how to do that properly. Okay, so this first one, log 7 base 5, if my instructor said, please tell me what this is, and I want you to approximate it to 4 decimals. Anytime they tell you they want you to approximate something to a certain number of decimals, that's a huge clue that you probably can't do this guy using normal log rules like the ones in the previous video, that we're most likely going to have to use change of base. And a quick scan of this, I can't really see any way where I could rewrite 7 as 5 to a power. You know, something like that might allow me to use one of those other log rules we learned before, but nothing comes to mind. And so that, in conjunction with these directions, pretty much says I should be doing change of base on this problem and then using a calculator. Okay, so this one I'm going to turn into the common log. So that says I'm going to write it as a log divided by a log. The 7 goes up top and the 5 goes down below. And again, it's going to be base 10. I'm going to do the common log on this one. And so now, in order to get this as a decimal, I'm going to put this in my calculator, okay? Before we do that, let's convert this one as well. This one, why don't we do as the natural log? Again, you can do them either way. You're going to get the same answer in the calculator. So let's practice writing this one using the natural log, and then we'll put them both in the calculator and see what we get. So using change of base on this, I am going to, again, I have a log divided by a log. They both happen to be the natural log. The 9 goes up top, the 4 goes down below. Okay, so now these are ready to put into my calculator, and let's see what we get. And according to the instructions on this one, it wants me to round it to 4 decimals. Just follow the directions. They may ask for 2 decimals, 3 decimals, 4 decimals, whatever they happen to specify is what you're going to want to do. Okay, so in this first one, let me pull up the Texas Instrument calculator, and you can see I'm going to do the common log on this problem. So I'm going to be using the common log button. Let me see if I can pull this up a little bit so you can see that screen better. So entering this in my calculator, I need to do the log of 7 divided by the log of 5. Okay, so the log, oops, let me turn it on. The log, notice that when I put that log button, my calculator automatically gives me this parenthesis here. So I'm going to enter the 7, and then I need to close out that parenthesis. That's telling my calculator that that's the only thing that I want inside of that log there. So this says the log of 7, and then I'm going to divide that by, again, I need to do the common log so that I stay consistent. Again, my calculator gave me that parenthesis. This time I'm going to put the 5 in, close out that parenthesis, and hit enter. When I do that, I get, big surprise, a decimal, 1.20906. The directions said to round it to 4 decimal places. So there's 1, 2, 3, 4. And if you remember your rounding rules, if this spot is 5, if the one next to the right is 5 or larger, we're going to bump this up. But if the one to the right is 4 or smaller, we'll leave this as a 0. So since this is a 6, that's 5 or larger, we're going to round this up to a 1. So I'm going to write my answer as 1.2091. So let me write that down. 1.2091. Now, again, the advice I suggest is let's do it twice. Make sure we get the same answer to try to eliminate the potential for any calculator mistakes. So I'm going to do, again, the log of 7, and I want to divide that by the log of 5. And I got the same answer, so I'm feeling pretty good about that, and I will move on. Okay, this next problem we have already rewritten using natural log, and I'll pull out the Casio for you Casio users, and we will do it with this calculator. Okay, so I've got the natural log divided by the natural log. So here on the Casio, here's my log buttons. So I'm going to do the natural log. So the natural log, and you can see again, it gave me that parenthesis there. I'm going to put a 9, and then I need to close that parenthesis. So that says the natural log of 9. Now I'm going to divide that by the natural log of 4. And again, I need to close that parenthesis. So that looks good. Natural log of 9 divided by the natural log of 4. I'm going to hit equals. And again, rounding to 4 decimals, I've got 1.58496. This is where that 4th decimal is. So the question is does it stay in 9 or do I bump it up to a 10? This is 5 or bigger, so I'm going to bump that up actually to a 10. By bumping this up to a 10, that also bumps that up to a 5 next door. So this answer, let me set that down, is 1.5850. rounded to 4 decimal places. And again, I would encourage you to repeat that in the calculator a second time, see if we can get the same answer. What I'm going to go ahead and do on this one is show you that it doesn't matter which log you use, natural log or common log. Let's repeat this same problem, but let's do the common log instead, and we're going to get the same answer. So we've got the log of 9 divided by the log of 4. And sure enough, we have the exact same answer that has come out of our calculator. So that is pretty much change of base. So again, you use this when your instructor gives you a log problem that they want you to evaluate, and either they can tell you to do change of base in the directions, or if they use those words, approximate to so many decimals, that's a clue that it's probably a change of base problem. Or sometimes they might just say evaluate this, and by looking at it, none of the other log rules apply. And so you pretty much know that you need to go grab your calculator and use the change of base process. Pretty straightforward. Again, I think it's one of the cleanest log rules. The biggest issue sometimes students run into is not knowing how to use those log buttons in the calculator. So it takes a little bit of practice. I encourage you to do several problems and convince yourself that you can work your calculator properly. And then you should be good to go on change of base.